Okay, today we've got Alan Pearce on the podcast. Thanks for jumping on, Al.
No worries. Pleasure to be here.
So I've been following your stuff for a couple of years now. I really love your research. The research I've seen you do, I think it probably relates to my listener base quite a bit. And we're going to cover those topics, talking about strength, unstable surface training, concussion. For the listeners that don't know who you are, can you tell us how you sort of started along that line of research?
Okay, so I've been around a long time. I'm pretty old. So my journey starts back from the 1990s, where I was born and grew up in Perth, and did my undergrad at Edith County University, in a Bachelor of Science in Biomedical Science. And I guess that's where it first started, because I did a fourth year, which is an honours year, where I looked at, I guess, the neuromuscular aspects of muscle damage. So delayed onset muscle soreness, so all that sort of stuff from eccentric exercise. You know, you wake up the next day and you're feeling like, oh, geez, where did those muscles come from? They hurt like buggery. So what I did was I looked at the central nervous system responses to that, and that's kind of where I started from. And then following that, I did a postgrad in sport and exercise science, and then I've also then did a PhD in neurophysiology, where I looked at the time it was very new and not quite understood, but the neuroplasticity, as we call it now, of skill acquisition. So I used a fancy technique called transcranial magnetic stimulation to look at the central nervous system. And I did basically sort of brain mapping of Olympic athletes who were involved in racket sports, because it's one side versus the other. So I can have a look and see what happens to the brain when people practice a lot with one side. So it's not something that I would generally say you should do anyway, but I just wanted to, it was more about like what's going on in the head. So once I sort of finished, I moved across to Melbourne, sort of did a few academic jobs, and then a guy called Dawson Kidgell came along, and some people may know Dawson, maybe not. He's sort of relatively quiet on the social media front, but certainly big in strength training. And so he and I started to get into understanding the neural mechanisms of strength and conditioning. And one of the first things that we wanted to look at was is the central nervous system doing when someone gets strong really quickly. And so we've done probably about 30 or 40 research projects looking at that. And we continue to do work today in that. And in particular, we're looking at what we call cross-education, which is training one limb and getting the other limb strong, because it's got rehabilitation, outcomes from that. But in the meantime, I then also kind of, and I do strength training research, sort of just, it sounds awful, but for fun, because it's really like I truly enjoy it, because it's good fun to find out what's going on. I'm certainly not an expert in training athletes like you are and what you do. I want to look at the sort of the mechanisms from a physiological perspective. But at the same time, I also sort of diverted off into brain injury, because I was really interested in understanding the neuroplasticity of brain injury. And that also started when I was doing my PhD with a colleague who was looking at stroke and trying to understand how the brain reorganizes and adapts, which is again what we call neuroplasticity following stroke. But I would then moved into brain injury, and then that led me to concussion in about 2009, 2010. And then shit hit the fan in about 2012, 13, when Greg Williams sort of basically came out to say that he's struggling with memory issues, mood disorders, based on his history of head injuries when he played for Carlton and a couple of other clubs, which I can't remember off the top of my head. So that's kind of, in short, where I lie. So I do both mainly concussion research now, but I also work with Dawson with strength training, and that's some of the stuff that we'll talk about.
Yeah, awesome. I love that, the skill acquisition stuff too. Like, well, that's one of the big things I get all our clients learning how to juggle.
Yep.
For that very reason, for the neuroplasticity, and you very quickly learn that one side of your body is not performing as well as the other side. So
Yes.
trying to balance that out.
Absolutely, and I think that's one. I guess one of the myths of that we can sort of start on already is that basically our brains have to work together across, and so juggling's really good because you've got to get both hemispheres communicating with each other. There's no strong evidence that the left side of the brain is for this and the right side of the brain is for that. And there's no myth. It's another myth that we only use 10% of our brains. Doing activities is required both sides of the brain. It requires all of the brain, because you've got to have frontal parts of the brain talking to the back part of the brain, which then talks to the motor area of the brain that makes your hands move and juggle. So it's what we actually now call functional connectivity. So it's a very important activity to do to engage the whole brain.
Yeah, 100%. It's I read somewhere, I can't remember where it was, but they did a study into high level athletes or world class athletes across all like golf, tennis, football, soccer, and what the top 10% of the high achievers across all those sports could perform the skill the same with each hand or each foot. Like, they could kick the ball the same with their left or right. They could use the racket the same with their left or right. So it's a quality that elite sports people share.
Yeah, absolutely. And it kind of shows the ability of that sort of elite of the elite to be able to, what they can do, through practice, and also some obviously genetics as well, having that nature versus nature nurture type scenario. You've got to have some obviously talent, but if you don't work at it, then you're not going to get anywhere. And you'll probably see a lot of potential in a lot of people, but they just don't put the amount of training in required. And that doesn't have to be the same thing over and over. It's doing different things to really engage the whole brain.
Yeah, exactly. Yeah, you're right. Some people have got that bit of gift of natural ability. If you haven't got that, you just got to, like you say, put in a bit more work to get there in the end.
Yeah, absolutely. And you do see the people who've made it who just have worked their asses off.
Yeah, exactly. So with the strength, I'd love to start there. I guess that's what sort of led me to in the first place when I started following you a couple of years ago, and that was through Christian at Woodford's. I did a bit of stuff, a couple of workshops down there with him, and he referenced you. That's when I started following you.
Right.
So the research you've done into the role of the nervous system and the role it plays in our ability to produce strength. So I think that's a big myth out there with people, which I'm sure you're well aware of, is that to think that to get stronger, we've got to put on muscle. And when we put on muscle, we're going to get bulky. When we get bulky, we're going to get slow. So, that's not the case. So can you tell us what you found in that area?
Yeah, well, I guess, with Dorse and I, we've always worked on the hypothesis that strength training and skill training have the same mechanisms in the brain, that is, for the central nervous system. And strength training is a form of skill training. So, and that's come from understanding that people can get strong really quickly in that sort of first 4 to 6 weeks without any muscle hypertrophy or any other morphological change in the muscle. And so, and interestingly, up until about 2006, despite probably 40 years of sports science, or, prior to that, physical education, whatever they wanted to call the term, prior to 1990, because sports science didn't really exist as a discipline until about around that time. It was more in the phys ed space, and that's something I didn't want to become. I was not a phys ed teacher. So apologies to the phys ed teachers out there, but sports science kind of evolved from that, and they sort of started around 1990. But interestingly, there was no understanding of how people got strong quickly until about 2006, when a guy called Caffarelli from the United States showed using TMS that people can get strong within 12 days or 6 days actually. And that was purely through the central nervous system activating the muscles. So what we were thinking was, okay, well, we've got to understand what is the nervous system's role. And what we were able to show is that the drive from the motor cortex and the brain to the muscle was what was actually improving strength, not, bulkiness or changes in the muscle itself. Down the track, you do get morphological change, but that whole myth about getting big I'm still surprised that myth is still around, despite the fact that we've got thousands of research studies demonstrating that it's not a quality of strength. Strength is a neural measure, a neural contribution to recruitment of muscle, and that's how you get strength, because strength is basically force production. And so if you don't have that ability to generate force, you won't get strength. It doesn't matter how big the muscle is. So I guess that's one of the things that we've got to try and keep telling people, is that by lifting weights you'll get strong, which is healthy, but you won't get big.
Yeah, well, I guess it comes back to that thing of the intent behind the movement as well, doesn't it? When we're trying to build strength, you can see people going through the motions with doing whatever the movement is, bringing in very little intent to the movement, which in turn is recruiting very little of the nervous system.
Yeah, and that's a lot of work that Dawes has shown as well, is that if we and obviously we have to preface this in the fact that in science we can't do necessarily movements that we'd like to look at, say, in the gym. So we have to try and use models to understand what's going on. So a lot of our work has been based around just a bicep curl, just to try and understand what's going on. Obviously we'd like to do multi-joint movements and whatnot, but that then reduces the rigor in the science and it makes it easier to people to attack. So and say that's bullshit. So what we have to do is, okay, well, let's just look at the bicep. Let's see what the bicep's doing.
Yeah.
And what we've found with that whole skill strength aspect is that we can get people just to do a movement at their own pace, and we can equalize the volume and the tonnage and the intensity. But what we've found is that the increased strength, but also increased neural drive to the muscle, is when we actually challenge the subject to work in a particular tempo. So it's not necessarily purely about time under tension, but it's them trying to match what we're asking them to do. Adds an element of skill to that. And what we've found is that people have gotten stronger, and we've seen an increase, central nervous system drive or integrity as a basis of that. And that's also helped with this cross-education phenomena as well. So we can get better outcomes through having a skill element to it. So it's doing the basics really well rather than just doing some fancy stuff.
Yeah, 100%. I like it. So, and I guess the other thing there with like people to actually put on muscle, for most people, it's actually quite difficult. Like, they don't understand how hard it is to actually build muscle. You've got to do a lot of volume and be eating a lot of food to actually get your body to produce mass.
That's right. And you've got to have a fairly, I guess, favourable somatotype as well.
Yeah, for sure.
If you look at some of the endurance athletes, they're doing a lot of endurance, but they're doing a lot of strength as well, and they're certainly not bulking up anywhere near what you would expect. And so, and you hear people all the time, I try everything and I just can't put on any muscle. Okay, I think that's telling you something.
Yeah.
But as you said, the myth's still there that I can't do weights because I want to get big.
Yeah. So what you must have, I see you do a fair bit of training yourself. You've obviously been been active and been into training to go down this path yourself in this research.
Yes. I've always enjoyed, getting in the gym and Again, I've been, I guess, a little bit lucky in the fact that I can put on a bit of muscle relatively easier. And I've always enjoyed doing high loads strength training. I've got to be a little bit careful now hitting 50. I've got a few chronic sort of injuries that I've got to try and maintain. I was a racket sport athlete when I was younger too, so I did a lot of repetition work, which now I'm paying the price for. Because back in the day, in the 80s, in the 90s, it was very much about repetition. Practice makes perfect, that sort of stuff, to the point where me and a lot of my mates who, one of my mates went to the Olympics in '96. He's now having, 2 hip transplants, because his hips are basically gone. So, we've got to be a lot more smarter in how we train athletes now, rather than just working on volume and repetition. We've got to learn, we've got to be better at and smarter at training. And so, yeah, I do a lot more about quality rather than the quantity. And I've been lucky enough to still, maintain a bit of bulk, which I'm happy with. Yeah.
Yeah, awesome. So what, sort of going back where we mentioned genetics before, that's another thing I've dabbled in research and reading into epigenetics. What's your thoughts there on, especially with long-term stuff like that? Like, obviously, athletes are putting themselves under a lot of load, repetitive movements, etc. They're supporting that with training in most cases. Do you think a lot of that does come down to the other, like, lifestyle factors, environment, nutrition, recovery, all those things?
Oh, absolutely. Yeah. I mean, we've got to look at the athlete as in a holistic sense, and as the recovery and, nutrition, diet is certainly as much as important, as the training. Because if you don't, my philosophy for strength and conditioning is really about getting the athlete healthy so that they can actually do the training on the court or on the field, where they actually get their sport-specific improvement. And
for sure.
Yeah, and for a while there, I guess in the 1990s, it was almost like the S&C or coach almost thought themselves a bit more important than the athlete, and was trying to do a whole bunch of stuff that was not necessarily evidence-based. And now we've sort of come full circle and realised that, okay, no, you can improve, the athlete improves through their training, but all, the understanding of nutrition, recovery, aspects of training in the gym or might be, conditioning, is about getting the athlete to be able to then go on to the court or field to do what they need to do to improve. You can't improve them as an S&C coach. You're there to be the support crew in order for them to be able to then go and improve, where they need to.
Yeah, 100%. I would agree for sure. I think that's where a lot of people try or possibly go wrong, is they're trying to replicate what they do in the skill of sport in the gym, and that's just not, it's not what the role of the gym's for.
That's right. And you certainly see, a lot of Instagram posts where you see athletes doing what I call circus tricks. And I just think, well, that's just, all you're doing is you're just, making them better at doing that particular skill, which we'll touch on later on. But just very quickly, I guess, one aspect of that, again, Dorse has been looking at, we might revisit it. It can be a little bit costly, and that can limit our research opportunities too. But, looking at brain-derived neurotrophic factor, BDNF, seems to be a key trait for, obviously, development of neuromuscular strength. So if we can tap it, look at the profile of someone, you can probably look at their neuroplastic changes and see who can respond to training better than others. But again, that takes us down a whole other track of potentially, what I'm going to call it, genetic screening, which you don't necessarily want to do, because does that discriminate talent? Sorry Ben, you just don't have that profile. We're not going to take it, mate. Sorry.
Good
luck. Yeah, good luck with what you do. Yeah, and so that's something that I think a lot of sports scientists are trying to grapple with at the moment. Is we're on the cusp of possibly screening, but then what happens? How do we deal with that? And particularly when we do see people who've come through sheer hard work, what sort of potential are we knocking out for those who are going to work that little bit harder than those who think, well, I've got the genetics, I'm going to be right,
Yeah, it's easy street.
Yes.
So that's probably a good segue into our next topic, what you mentioned before, the circus tricks. It's I guess it's probably not that different in field sports as well, but it's a big thing in our sport of motocross is people training on Bosu balls, Swiss balls, unstable surfaces. Yeah. Like you say, looks cool on Instagram, gets plenty of likes, but tell us about the research you did there and the findings you found when we compare a stable surface to an unstable surface.
Yeah, so this again sort of came from the early 2000s when Bosu balls and Swiss balls started to infiltrate gyms, and there were a lot of people around that time making, again, unsubstantiated claims about the ability of training on these unstable surfaces, whether it's Bosu ball or whether it's a stadiometer type thing or whatever, was going to increase your strength significantly because you are now recruiting more muscle during the exercise, and therefore it'll translate into your sport or general strength. So around 2006, myself and another guy, Craig Goodman, who's a muscle physiologist and does a lot of work with, looks at taurine and how taurine, sort of influences strength outcomes and that sort of, muscle morphology. We kind of just went, this just doesn't seem to make sense. So we were able to pull together, a study where we just simply compared a bench press on a Swiss ball versus a bench press on a traditional bench. And it was going to be looking at 1RM strength, because the first question that we wanted to answer was, if you're on a Swiss ball, can you basically push out a 1RM that's exactly the same as being on a bench? Yeah. Because again, you would read a fair amount of, and this came a lot from the glossy type magazine, strength magazines, where whoever was writing would say, well, you got to make sure that you drop your load by 60% because you're on an unstable surface, and but you're doing the equivalent of doing a 1RM on a bench. Yeah. Like, all right, that's interesting. So what we basically did was we obviously had two groups. We wanted to work out the 1RM on a bench, and then we did a 1RM on a Swiss ball. And funnily enough, we didn't find a difference. So whoever was, and we obviously crossed over. So whatever you did on a bench, and some of the guys were punching out 120s, 130, 1RMs, and then getting on the Swiss ball and doing exactly the same thing. Yeah. So, the only concern that we had was that maybe the Swiss ball might burst, but, we obviously didn't. They're designed to take a fair amount of weight. So we had no problems there. And then the second phase of the study was to look at 4 weeks of training either on a Swiss ball or on a bench press. So we obviously divided the groups up, equaled for their 1RM outcome, trained 3 times a week. We did from memory, I think we did a pyramid type periodization. So 12, 10, 8, 10, 12, we kind of tried to mix it up over that 4 weeks. And then we just tested them at the end of the 4 weeks for their 1RM again. And what we found was that there was, and we, I guess as they sort of progressed, we would also change their weight so that we were constantly getting them to improve. And what we found was that the improvement was no different in the whatever you train on. I was trying to say. So if you train on the bench press, you improve by the same percentage as what you trained on the Swiss ball. Yeah. If you crossed over, then it wasn't so good. So what we found was that it was apparatus specific. Yeah. So for people who train on a Swiss ball, they got better on a Swiss ball. If they train on a bench press, they got better on a bench press. So it didn't matter. So what I guess the moral of the story, or the take home of the story, is that what you're doing is you're getting better on that particular apparatus. You're not actually transferring that to something else. So yeah, if you are training on a Swiss ball and then trying to get onto the bike, it's unlikely, based on what we've seen, that you're gonna get that transfer onto the bike, because that bike has got a different set of motor control parameters to a Swiss ball or a Bosu ball. So yeah. And you see it anecdotally too. I mean, it doesn't matter if it's on the bike or if it's on a soccer field or whatever. You still see them going, well, I've just been doing all this sort of balance work, yet I can't seem to. I thought I'd get better at changing direction or not tripping over when I get tackled or whatever. I don't know what's going on. Well, it's because it's not sport specific. So that's essentially the what we were finding, and I think it has been repeated quite a bit. So the discussions about is that I'm not anti-Swiss ball or anti-bench. I'm just saying mix it up. Yeah. Keep some variety, So don't think that one is better than the other.
Yeah, I would say the same. I think if you want to use one. But if you think you're using it to make yourself better and it's actually improving you, then it's probably not.
No, right.
Yeah, you're getting better at the skill of standing on a Bosu ball. But in our sport, I think people are good at standing on a Bosu ball because they're good at riding a bike, not the other way around.
Yeah, that's right. Exactly. Because, if you think about, they're on the bike a lot more than on the Bosu ball, so they can transfer that skill from the bike onto the Bosu ball.
Yeah.
But you're definitely right. It's about getting good on what you need to be getting good at.
Exactly. Yeah. So when you say there was no difference, it's probably just, if we can clarify that, like you had those people hooked up, they had the little sensors all over them. So there was because that's one thing people will say, it fires up all your muscles to stabilize, blah, blah, blah.
Yeah.
But that's when you say it was the same, they were recruiting exactly the same muscle.
Yeah. Well, that's right. Yeah. Thanks for reminding me. I actually forgot about the fact that we did a 12-channel EMG, not ECG or EEG. I get my electrophysiology all mixed up now. So EMG, electromyography. So we had trunk muscles, abdominal muscles, back muscles hooked up, and what we found with the amplitude of the EMG. So as a muscle contracts, it will fire, and you see this squiggly line, and we can look at the amplitude, we can look at the frequency it's firing at. Basically, what we found was that there was no difference during the actual activity itself. So the muscle was basically firing to generate the force required to produce to be able to push the muscle, not because they were on a Bosu ball or whether they were on a bench. So even when we hypothesized that the bench would support and obviously drop the amplitude of the EMG because they had their back to be able to push it, what we were finding was that they were actually using the bench to activate the muscle. So it was just a strategy of the body, not the actual apparatus that was doing the work.
Well, it comes back to that intent thing again, doesn't it? Like if you're just flopping on a bench and doing a bench press, not creating any tension, you're not going to recruit as much muscle. It's the same whether it's a squat, whether it's a lunge, whatever exercise you're doing. If you're doing it with intent and you're getting coached well on it, then you will be recruiting every muscle in your body.
Exactly. And we actually start to see this now in neurological diseases. So there's a similar principles coming across in Parkinson's disease. So what they're finding is that if people with the early phase of Parkinson's, where they might be getting the tremoring and affecting their movement, and they've got to take a drug called levodopa to help them move again or stop the tremoring. What they've found in America is that if they do either high intensity cycling with a tandem, so they're trying to match someone, so there's that intent, they actually don't need their levodopa for a good week or two after that, because they've had such a good modulation response in their brain. And a similar thing is being shown as well with strength training. So if Parkinson's patients are doing strength training, they're getting similar outcomes as well, because there's intent in the movement. So, that's where I'm hoping that some of that will start to come across to Australia a bit more, because we're still quite, worried about hurting people with neurological disease, and what they need is good quality exercise.
Exactly. Yeah.
So yes, so going back to your athletes, we know that this works because, but it needs intent and it needs quality of the movement that will then get the neuromuscular response.
Yeah, for sure. So that's probably another good segue into the concussion stuff, with the segueing off the Parkinson's, because there's like, as you well know, I suppose there's quite a bit of research now showing the link between, I guess, neurological degeneration from concussion, etc. And in our sport, motocross, it's like pretty much everyone that's raced motocross has had a knock to the head at one stage. So the really cool thing, I listened to one of your other podcasts, you did the Two Wolves podcast.
Yeah.
And the thing that blew my mind there, which after I thought about it made sense, but you brought up that topic that helmets don't actually protect our brain.
That's right.
It protects our skull per se, but it's the impact on the brain is still the same. So that, like, when I think about it, it's like, that actually makes sense. But I didn't really think about, you kind of think, I've got a helmet on, okay. If I get a knock to the head, I'll be fine. It doesn't matter. That's
right. What what I call that, where people feel that if they're wearing a helmet, they're going to be more protected, is what I call the superhero complex. So what happens is that they wear a helmet and they start to feel like they're going to be invincible. But in saying that, obviously, I ride a bike. It's not a motorbike. It's a road bike. But I will, irrespective of the laws, I would probably still wear a helmet when I'm on the road cycling, for the reason that it does protect my skull from any fractures. But I'm fully aware that I could be concussed, and the reason for that is that the brain is sitting inside a bath of fluid, and it's only a few millimeters, or even that, but and that's known as the cerebrospinal fluid, and that gives nutrients to the brain, it gives oxygen, it takes out carbon dioxide, waste products, so it's there to obviously for the health of the brain. But one of the roles of the cerebrospinal fluid is also to cushion it a little bit against the skull. Now, if you walk somewhere and you bump your head, damn, the cerebrospinal fluid is helpful for that. If you're doing some, squat jumps, that sort of stuff, cerebrospinal fluid is good for that, because it's just cushioning the brain so it doesn't sort of hit the skull. Yeah. But when you start to get above, 20, 30 G type hits, so 1 G force is 1 gravitational force of the Earth. If you're doing 20 or 30 times that, so 20 or 30 G, that or more, that starts to work against you, because the brain still keeps moving when you get an impact to the head, whether it's falling off the bike or whether it's colliding into an opponent or whatever. So that brain still keeps moving, and one of the things that we have to understand is that the brain is very delicate. So it's basically not like what you do in human biology at school and you cut up a sheep's brain. That's a fixed brain. A unfixed brain is like a little bit thicker than custard. But if I, was a bit, Frankensteinish, and I opened up your head and I pulled out your brain, I could squeeze it through my fingers, and that's how delicate our brains are. Yeah, right. So the other part too is that the outer part of the brain is grey and the inner part is white. And the white parts of the brain help the grey parts of the brain talk to each other. And that's that functional connectivity that we were talking about earlier in the session.
Yeah.
And they have different consistencies. So what you have is not only the brain moving, but you have the brain moving at different rates. And that stretches and shears the brain cells or the neurons. And so in a concussion, that's what's happening. So the brain moving, different parts of the brain are moving, they're putting stress and strain on the neurons. And so when you do come off the bike, whilst you might not actually have had any fractures to the skull, your brain has probably had some trauma to it. So what I try and tell people, and it doesn't matter if it's motocross, cycling, or even equestrian. If you come off the bike or your horse and you get up, concussion is not a loss of consciousness. In 90% of the times, a concussion, there's no loss of consciousness. But if you come off the bike and you see some stars, if you feel a bit confused, if you're a bit unbalanced, if you're feeling a bit of a headache, they're signs. They're 4 of about 15 different signs and symptoms of concussion. So the last thing that I would recommend is that if you do come off the bike like that and you start to feel that there's something not quite right, foggy, don't get back on the bike, because your brain is not able to process and you're putting yourself at higher risk of further injury.
Yeah, for sure. It's something you'll see it all the time. People get. I've been guilty of it myself before. You'll have a hit in a race, like your number one goal in a race is to get to the finish line, and if you can walk, most people will try and get back on the bike. So they're trying to get back on. You can see they're stumbling around.
That's right, and I guess that's that's where the guidelines for motocross need to be enforced by the organisers, because earlier this year there was a coronial inquest in New South Wales for 3 equestrian riders who died while competing, and you don't want to have the same thing happening in motocross where it could be prevented. Now I guess one of the things, I don't know really motocross well enough on whether any riders retire prematurely for their career, but in football, Australian rules football in particular, we've seen nearly 24 young guys retire before the age of 26 or 27 years of age in absolute tears, because they can no longer play the sport they love because they've had too many concussions. Now, being a little bit preventative, cautious, taking an extra week off and doing good rehab post-concussion can actually probably extend your career by maybe 5 or 6 or even 10 years. I don't know how long motocross riders can ride for, but for football, you could extend a player's career by maybe 3 to 5 years if they just took a little bit extra couple of weeks rather than trying to rush back into it too quickly.
Yeah, well, that was going to be one of my questions. What would you recommend for people, like if they have had even if, like you say, like you don't have to be knocked out to, obviously if you're knocked out, it's pretty serious, but you don't have to be fully knocked out to have a serious concussion. So what do you recommend for people in that recovery period?
Well, I guess the first thing is that if in doubt, sit it out. So if you, or whoever you train or a parent of a younger junior rider suspects that they're concussed, sit them out and observe and watch, because only a medical doctor can diagnose a concussion. So if it is obviously, obvious symptoms, then get to a hospital or a clinic to get properly diagnosed. But from there, we need to implement some more exercise rehabilitation and exercise. You guys and yourself are in a perfect position to improve recovery outcomes. So up until 2017, despite the evidence emerging for probably a good 4 to 5 years prior to that, it was suggested that if you were concussed, you do nothing for at least a week. So you sit in a dark room, you don't go to school or work, you don't do any physical exercise, And what we found was that people were getting quite depressed very quickly because they were just not allowed to do anything. And I mean, if you imagine, I told you no, you can't do anything for the next 5 to 6 days, you know, how would you feel about that? Sorry, you can't wait to do that. That's too much for your brain. You know, it was just, you know, pervasive everywhere. And so what we now know is that if you are concussed, obviously you've got to let the symptoms subside. It might be a day or so or two. That doesn't mean that the brain hasn't recovered, but what we need to do is start to allow the brain to start to recover more effectively. So light aerobic exercise, possibly light strength training, just you know, nothing that brings on symptoms, but it's something to start to get the brain to, you know, actively rehabilitate the same way as you would for a musculoskeletal. You know, you don't get them just to sit out and do anything. You try and get them into some sort of active recovery rather than just passive. And so, you know, one of the things that we want to try and stress is that, you know, as long as it's not bringing on symptoms, you can actually start to do some light exercise and some light cognitive stimulation as well. So, you know, even getting them to do some juggling might be good because it's stimulating their brain to do something that's not stressing the brain too much. And so this is, you know, and it's a graduated improvement. So as you start to see the client every second or third day, maybe in this rehabilitation space, then you can actually start to gauge, okay, how much more can we start to build up? No, we can't do it. We've got to bring it back because they're starting to show some symptoms. So it's a bit of honesty from the athlete themselves as well. But by giving some active recovery or active rehabilitation, what we're seeing are better outcomes. It may not necessarily mean that they're going to get recovered quicker, but certainly they're going to get better outcomes in the long term.
Yeah, for sure. So I guess it comes like anything, comes back to listening to your body a bit and not just feeling your way with it, doing what you can, but not pushing too hard if you feel.
Yeah, that's right. I mean, there is some stuff where, you know, it's called the Buffalo treadmill test, or Buffalo concussion treadmill test, where you can actually gauge exactly what heart rate you can work at before symptoms start to come on. So you can actually refine the real rehabilitation rather than a more guesswork approach. So, again, it's, you know, I spoke to a bunch of exercise physiologists about 2 weeks ago who had never heard of the Buffalo concussion protocol. And I said, well, that doesn't surprise me because for some reason, I think there's maybe only 1, possibly 2 places in Australia that have actually implemented the Buffalo concussion protocol. And it's very easy. It's really simple. All you need is a treadmill and a heart rate monitor. You could even do it on a bike. There's a bike protocol now on a bike at Ergo. But it's just a very general, you know, graduated approach until you start to, you know, and you get the ratings of perceived exertion, and you also just get the perceived symptoms from the athlete themselves as well. Yeah,
awesome. I like it.
I can send you that. That's easy.
That'd be great. That'd be great for sure. Yeah, 100%. Yeah, like I say, it's a pretty common thing, and I even had a whack to the head earlier this year. Pretty serious. Didn't get knocked out, but was seeing stars for a couple of hours. That's for sure. So and like I say, I definitely had to take it easy for a week or so.
Yeah. And what we know too is that, you know, symptoms might resolve within minutes to maybe a few days to a week, but we do know that brain recovery through the physiological research that myself and others have done in the United States is that it might take about 30 days to 40 days before the brain has fully recovered. And so, you know, we've got to try and get athletes to understand that your symptoms are gone, but that doesn't mean that your brain hasn't healed. The same way as maybe the core key has resolved, but, you know, there might still be some underlying damage to the to the musculature. So we don't, if you're coming back from a hamstring tear or a severe corky, you're not going to go straight back into full training. You've got to rebuild that, or else you're at risk of further injury. And we see that with concussion as well. So, we know that you have a risk of nearly threefold risk of further concussions if you have had a concussion, but we also know that there's a 2 to 2.5-fold increased risk of a musculoskeletal injury following a concussion for that next 12 months as well.
Yeah, right. That's interesting. Yeah, and it's a tough one. Like people, especially athletes, are competitive, and they can see their goals get like edging away from them. You want to keep. If you feel it's one of those invisible things, a concussion. You can't actually see it. You haven't got a visible injury, so you are inclined to just start going hard again.
Oh, absolutely. And this is the thing, it's the invisible injury. So, whilst people are quite happy to, or they understand that they've got to, with a musculoskeletal injury, rebuild, it doesn't seem to be the same for the brain, which is a concern because, the brain controls basically everything else in the body. But we don't seem to give it the same respect as we do a quad or a hammy or a shoulder or something like that for some reason. So we've got to change the culture towards brain injuries a little bit more than, and particularly at the sub-elite and club levels, the attitudes are still not changed. Whereas at the elite levels, they're starting to understand that, okay, yeah, I'm actually better off, and I'm being more committed to my teammates, if I take time out, I don't try and push it, or I don't try and go back on the field in the same game, because if I don't know which way I'm kicking, how am I supposed to be helpful to my teammates? But for some reason, athletes seem to think that means that they're committed. So we've got to try and work on changing that. But you're better off looking after yourself for longer term, but you're also going to be better off, looking after your teammates as well. And and I guess other riders too. If you're riding and you're not quite 100%, you're putting not only yourself at risk, but you might be putting other riders at risk if you crash into them.
Yeah, 100% for sure. Yeah. So it comes back to more education.
Yes, absolutely.
So that's why I'd like to thank you for coming on the podcast, Al, for that very reason, to be able to educate listeners and the wider audience. I really appreciate it.
Certainly appreciate it, and certainly appreciate the support too. And if anyone's listening out there, the research, we need to do a huge amount more in the research area of particularly of concussion. And so one of the things that I try and do is support the Australian Sports Brain Bank that is trying to understand this issue, both from a long-term perspective, but also with short-term stuff that we've been talking about as well. So, if anyone's able to help us out with the Australian Sports Brain Bank, just Google that, and it's at the Royal Prince Alfred Hospital in Sydney under the direction of Michael Buckland.
Awesome. And can people check out your research there? Where can they sort of get hold of that stuff?
So I guess you can also have a look at my stuff through my own website, which is neuropearce.com. And I also have some academic research sites as well. So I think if you Google Alan Pearce Academia and Alan Pearce ResearchGate, you'll find all the sort of stuff, particularly in strength training. I've put all that stuff up there as well. So, but anyone can email me, and I'm more than happy to send the papers for educational purposes.
Yeah, awesome, Al. Appreciate that.
No worries.
Thank you very much, Al, for jumping on board today.
Happy to. Thanks very much for having me.
You're a man of much knowledge.
Oh, when you've been around as long as I have, I suppose you acquire something, when you're old man. Yeah.
Well, it's true. You can only get better with age, I say.
Like a fine wine.
100%. Thanks, Al.
No worries. Thanks very much.